The next topic we're going to cover today is going to discuss some different terms in relation to digital imaging, be that different color types, different file types, and some differences between print and web imagery. Now, in regards to color, what you print and what you see on screen are not always the same thing. I'm going to pull up a graphic as an example. So RGB, which is over here on the right, is for displays only. And by display, I mean digital display. So the reason RGB, or red, green, blue, is important is that they are the primary colors as they are defined by light. All right. This means that these are the colors that are used when something's being backlit. So any output device, it can be your computer screen, your television, your iPod, your mobile phone, the screen on the back of your digital camera, every one of these displays is going to use an RGB color matrix to produce the colors that you see. Now, CMYK, so these stand for cyan, magenta, yellow, and K is black. These are the primary colors used for printing inks. So rather than emitted light, these represent reflected light. Most full color printing is accomplished using these four colors. So if you have a printer that has more than a black ink cartridge, you'll either, if you have experience with that, you'll notice that either you have separate cartridges for every one of these colors, or you will have a color cartridge that perhaps has icons of these particular shades on the outside. So it's important to recognize when certain color types are being used, because when we work with digital imaging, saving your files as certain file types will make sure that they have the best possible visual outcome that they can have. They're the most bright and vibrant and clear. As another visual example as to why CMYK and RGB are important, I'm going to show another image. This particular photograph is identical. One side is RGB, one side is CMYK. Because most likely you are viewing this video on a device that is backlit, whether it's a computer screen or a tablet or whatnot, it is going to be displayed to you in RGB. So the left image is formatted in RGB. The right image, you can see it's not quite as vibrant. The reds and the oranges aren't quite as punchy. It's almost like there's a faint fog over the image as you look at it. This image on the right is formatted in CMYK. If I were to print this photograph, these two side-by-side images, out of a printer, the vibrancy would be reversed. The one on the right side would be more vibrant, the one on the left side would be more dull. So this is a quick visual representation of why these color shifts are so important. The next topic we're going to discuss is the differences between print resolution and web resolution. We've already discussed color and why color, print versus web, is different, but resolution applies as well. Now, the term resolution refers to the sharpness or clarity of an image. The higher the resolution, the more sharp and clear that image is. The lower the resolution, the more dull, the less color information there is available, the less crisp and clean it appears. So I've got, again, two images side by side. One of these are in print resolution, one of these are in web resolution. A traditional rule for printed images is that the minimum print resolution should be 300 dpi, meaning dots per inch. In the case of printers, the resolution in terms of dpi, or dots per inch, pertain to a printer that can print 300 distinct dots in a line that is 1 inch long. Now, if you were to do this on your computer, chances are you wouldn't see 300 distinct dots without use of a microscope, or at least maybe a magnifying glass or something. But that's what the 300 dpi, or dots per inch, pertains to. A higher resolution image results in more accurate color. There's a lot more sharpness and clarity because there's more pixel information supplied. In contrast, web resolution is only 72 dpi, or dots per inch. This is for a few different reasons. Part of the reason is that most computer monitors are 72 pixels per inch displays. This, depending on what you're using as a computer monitor these days, can vary. I know a lot of students that have small televisions as their computer monitors these days, so that is up for a little, there's a little leeway there. But also, it's important to recognize that web images, if an image is saved specifically for web, it's not only smaller in DPI, but it's also set up for RGB color format. Now, there are a few reasons you would want to use web resolution. You can see print in this case is on the left side and web resolution's on the right side. And most people would look at the web resolution and say, ew, that looks terrible. But there are some methods to the madness of saving it this way. Part of the reason it is secure, that meaning, let's say you put up a graphic or something that you designed, or maybe a photograph online, and you wanted to make sure that other people couldn't steal your information or your property. Saving an image as web resolution degrades to a degree the quality of the image. So if someone were to download this photo in web resolution and try to print it out large, they most likely would not get a very good end result. Another perk to having a web resolution saved file, because there's less pixel information, the file size is smaller. If the file size is smaller, it loads faster on the web, so that's an additional perk. So it's there as protection, it'll come out blurry or fuzzy if someone tries to print it, and images load faster when used on the web. So those are some reasons that print versus web is important. An added term that is important to recognize: in some cases, such as when we start using Photoshop, sometimes DPI is used, sometimes PPI is used. So we just discussed DPI is dots per inch. That is used in relation to printing. If you hear the term PPI, that is points per inch. That references pixels. So PPI pertains to web or digital-based imagery. DPI refers to print-based imagery. And the reason I mention that is that there is going to be a question on the quiz pertaining to that fact. Lastly, we're going to discuss the differences between vector-based imagery and raster-based imagery. So raster is something that you interact with on a daily basis, and you probably don't even realize it. A raster image is composed of pixels, with each pixel having a specific value. So any photograph, anywhere, any graphic, any logo that you've seen on a website, each one of these items are considered a raster item. What that means is the pixels are only a finite size. They cannot get any bigger than they were designed. So if an image has a higher pixel ratio, the pixels don't get any bigger, there's just more of them, which is what results in clarity. So every photo, every JPEG file is a raster image. Now, raster images have perks in that they are a compressed file because they have a finite size that tend to be a smaller or a compressed size file. But one of the downsides of raster imagery is that they aren't as flexible. If you took a photograph and you wanted to blow it up to be the size of the billboard, without careful planning, you risk pixelating that image. Now, the difference between a vector and a raster is that a vector image is composed of a mathematic equation or a mathematic set of instructions when you create it in software. And that instructions tell that shape or that object how to form shapes with specific values that don't use pixels. So it's math-based. So on the downside, a vector image, because it's math-based, it's constantly, cranking out numbers if that image is resized. It is a much larger file type, but as a positive, a vector image can be scaled to any size whatsoever and retain its sharpness. So if you wanted a logo the size of a postage stamp, or a logo the size of a billboard, or something big enough to put on the side of like a satellite or a space station, if you're using vector imagery, it would maintain the crispness and quality of that image. Whereas if it were a raster image, it would become blurry. And as you can see here, the example on the left is vector, the example on the right is raster, and each have their positives and negatives. I bring this up because we will be using both raster and vector imagery throughout the term, so it's an important term to understand.